Hey everyone, guess what? We're on the brink of something huge. Fusion energy, the holy grail of nuclear power, is tantalizingly close to becoming a reality. And leading the charge is Commonwealth Fusion Systems, or CFS, in collaboration with MIT's Plasma Science and Fusion Center. That's right, over in Devens, Massachusetts, CFS is preparing to ship its first fusion devices by the early 2030s. This marks a significant milestone in the journey toward harnessing fusion energy, a feat that has eluded scientists for decades. Their state-of-the-art facility is focused on precision production of giant superconducting magnets. Fusion energy promises clean and virtually limitless power, without the drawbacks of weapons proliferation or radioactive waste. Governments worldwide have invested billions in fusion research, supporting large-scale projects like the Joint European Torus and the International Thermonuclear Experimental Reactor. But CFS stands out in the commercial race. They've raised over $2 billion from investors including ENI and Bill Gates' Breakthrough Energy. Absolutely. There are two main approaches to achieving fusion magnetic fusion energy, or MFE, and inertial fusion energy, or IFE. MFE, particularly the tokamak design, is seen as the front-runner. This method uses superconducting magnets to contain plasma at millions of degrees within a magnetic bottle. The challenge here isn't the plasma itself, but maintaining the magnetic containment. And this is where CFS's groundbreaking development comes in. They use superconducting wire, known as HTS, wound into Viper cable or NINT pancakes to create powerful magnets. These innovations allow a significant amount of current to flow through the magnets, making the devices much smaller and more efficient. The first demonstration device, Spark, is expected to become operational next year, followed by the commercial device ARKey, potentially deployed within a decade. Brandon Sorbaum, co-founder and chief scientist at CFS, says the key advancement is in the superconducting magnets that have enabled the design of much smaller and more powerful fusion devices. This progress could herald a new era of abundant zero-carbon energy. It's truly mind-blowing to think how close we are to achieving fusion power. A cleaner, more sustainable future might just be around the corner thanks to the brilliant minds at CFS and MIT. So stay tuned, folks! The future of energy is looking brighter than ever. Until next time, keep exploring and stay curious.